Unlike the mainstream big tech companies in the US that have developed by simply scaling up, there seems to be a shift towards improving algorithms, and the results of this approach are now emerging. Hello, I'm Error, enjoying the Lunar New Year holiday. DeepSeek has become a global sensation. Taking advantage of this, it is riding the wave with great enthusiasm. They have just unveiled another multimodal AI model called Janus-Pro. It is also released under the MIT license, making it an open source model. The performance of this model is exceptionally remarkable, wouldn't you agree? When it comes to generating images and comparing these capabilities to advanced models, this AI demonstrates superior performance. Amidst the fierce AI competition, it is astonishing that China has managed to present a model that surpasses OpenAI's top models using only hardware like the H800 GPU, driven by reinforcement learning, similar to DeepSeek R1. The key point is that the specific AI model architecture, based on reinforcement learning algorithms, possesses significant power. Interestingly, this isn't limited to text models, it extends to image models as well. They've published a paper outlining these differences, and you can find everything on GitHub. Let's revisit China's AI advancement. On GitHub, you'll come across the DeepSeek model. You'll also notice the pinned version 3 model that was released last month, which is highly notable. This model is designed for general use. The announcement of DeepSeek R1 last week created a global uproar. Since the release of V3, the AI community has been abuzz with excitement. You see it says Janus here, right? This model is also under the MIT license and is described as a unified multimodal understanding and generation model, which means it can comprehend and generate images effectively. As the tide comes in, as you can see, the water is coming in, and when R1 water flows in, it provides a nozzle for the water. This is when they released Janus-Pro. You can see it now. This is a more advanced version than the previous Janus model. Let's take a closer look at it. In terms of multimodality, we need to be able to analyze an image to understand what it depicts, and also be capable of generating new images from text inputs. This model excels in multimodal understanding, meaning it can comprehend the elements and context within an image. Moreover, it emphasizes the capability to generate images as well. They are saying that text models aren't the only impressive ones. They achieved this with a remarkably compact model. Initially, they highlighted its performance. On the horizontal axis, the number of parameters ranges from 1 billion to about 7 billion. It extends up to 10.5 billion. You can see it outperforms the 10.5 billion XL version on average, can't you? Now they're releasing the Janus-Pro 7 billion. They're addressing issues one by one. There have been many series before this. While Janus-Pro is remarkable, do you see the graph on the right? The 1 billion and 7 billion models have high performance. Even the 1 billion model is impressive, but the 7 billion model performs even better. That's what they are discussing. Janus is on a similar path of continuous improvement, just like how we present slightly advanced models in our research papers. However, DeepSeek R1 is currently attracting attention. It appears that they are actively spreading this information, and the fact that it is open source is quite significant and somewhat intimidating. The model, known as Gen-Eval, assesses the accuracy of image generation from text, and it is noteworthy that it performs better than all existing models, including Stable Diffusion 1.5 and DALL-E 3 in terms of precision. This means that the expression is quite different between Janus and Janus-Pro. You can see that it is significantly more advanced. In the case of the DPG benchmark, it evaluates how well it handles very long prompts, and it is reported to achieve higher scores than DALL-E 3 or Stable Diffusion 3 Medium. So these are the things we know to be quite famous. It comes out even better, and it's open sourced among other things. So what did it use, and how much better did it turn out? Before we look at the details, shall we take a look at these pictures? Now, Janus was like this, but this isn't usable. The previous version of Janus was at this level, but now it works this well. It's not just a feeling that it works well. It's a bit ambiguous because large models generate so well. Even here you can see that the text is generated extremely well. This is roughly the feeling. The wine glass is also expressed very well. What exactly did they use? If we examine how well it performs, this architecture is the main component. It's crucial to grasp the architecture utilized in this model, as it presents a departure from traditional methods. Normally, standard models employ the same mechanism for both image comprehension and generation, commonly known as a visual encoder. This visual encoder is essential for translating images into data that AI systems can understand and process efficiently. When we look at a picture with our eyes, our brain interprets what it is, right? Similarly, the visual encoder in AI functions to transform images into numerical data, specific numerical data. It can create images and identify objects in photos, like recognizing a dog or deciding to draw a puppy when generating an image. This task of providing such detailed information is managed by the visual encoder. Previously, a single encoder was used for both analyzing and generating images, as seen in OpenAI and Meta, for the sake of simplicity. The structure is simpler, but what is the issue with using the same encoder? In the end, it's due to the gap between understanding and generating. The minimum performance isn't achieved. Listening to English and speaking it are different, right? There are people who are great at listening but struggle with speaking, or vice versa, right? Similarly, we can appreciate art, but replicating it is different. From the standpoint of requiring specialized and tailored tools, instead of using an identical visual encoder for all tasks, as you can observe, we have distinctly separated the components that comprehend images from those that generate them. This distinction is a pivotal feature. The understanding encoder is crucial in transforming images into high-dimensional semantic representations. This process includes using text tokenizers and detokenizers to segment and analyze the text, which is then fed into an autoregressive transformer. Additionally, the generation encoder takes images, converts them into specific codes or tokens, and uses these tokens to create new content. So, through tokenization, we input the data and use the generation code to utilize the image decoder. Ultimately, understanding and creation need to be intertwined. Observing art in a museum is quite different from actually creating it. Models like DALL-E 3 or Stable Diffusion focus on image generation, so they lack precision in understanding scenes with text. They were somewhat lacking in this aspect. Then, utilizing this architecture, we move forward to optimize these models, and this aspect is actually quite intriguing. Even though there were stages 1, 2, and 3 previously, something always felt a bit unsettling or incomplete despite their existence. Let's take a closer look at what exactly felt off about this training strategy, as it had some specific issues. The previous method was inefficient, so we made some adjustments. As you can see, we extended stage 1 significantly during the training process. Have you heard of ImageNet, the large-scale image dataset? ImageNet is a large image dataset. It was created by Stanford and Princeton researchers in 2009. It contains about 14 million images. In this process, the model labels images with tags like, "This is a dog," "This is a tree," or "This is a car," almost as if it is learning vocabulary words. Using these labels, it undergoes training in stage 1, and to handle the data effectively, we plan to significantly extend the training duration. Then, in stage 2, they excluded the training data deemed inefficient and appropriately replaced it with data suitable for practical applications. Next, in stage 3, adjustments were made to the data ratios due to the initially low quality of the data. The goal was to refine the integration of text and multimodal text-image data, which appears to have been done experimentally. Additionally, they significantly increased the data input to enhance the comprehension between multimodal text and images. In order to significantly enhance the existing dataset, they incorporated an additional 90 million samples, which included a variety of documents, tables, and charts. Moreover, to further improve the capabilities of visual generation, they added another 72 million synthetic samples, as the original dataset was considered to be quite insufficient. Therefore, synthetic data was incorporated instead of real-world data. This synthetic data was added specifically for this purpose. Each time these processes are carried out, AI chips are indispensable. Despite being available as open source, AI chips remain crucial for fine-tuning and other operations. Subsequently, Janus transitioned from 1.5 billion parameters to later, they expanded the model to 7 billion parameters, significantly enhancing its performance. You can go over the detailed scores at your own pace, so let's focus on the implications instead. Right now, we have evaluated the leading multimodal understanding benchmarks. Can you see this? We have distinguished between the understanding model and the understanding generation model, and as you can see, Janus performs exceptionally well in the green highlighted areas. If you scroll down, you will find more results. For text-to-image generation, the high scores are highlighted. While these results are impressive, integrating understanding and generation shows even better performance. In other areas, the scores indicate excellent performance, which is important to acknowledge. But is everything perfect? Not quite. We need to consider the limitations. For instance, it only supports a resolution of 384 by 384 pixels. The current resolution is quite low, making it rather challenging to manage higher resolutions. Additionally, image descriptions and text recognition are said to work well. However, there are still some limitations in precise text recognition. This might be because the model is still small. It seems to have some limits compared to those run on our usual servers. Therefore, we need to gradually improve the resolution. We are discussing this by saying, we have this technology too. I experimented with the Janus-Pro 7 model, and it generated an image saying, "Birds look like tennis balls." While the generation is impressive, can you notice the drop in resolution? It might seem skeletal, but it generates these well. Since it is all open source, anyone can run it for free. There are still issues like faces getting distorted. On the other hand, it can depict dragon eyes intricately. We need to apply scaling more effectively. Looking at this, you might think its realism is still lacking. If you check similar models, you will find many like this. This one feels like it is from the mate room. Anyway, many models are emerging. Not all of them are perfect. With DeepSeek and Janus, I used a smaller model with 1 billion parameters to draw Super Mario. It did okay, but understanding is still lacking. Actually, it's not fair to compare this with Grok. Grok is ahead since it runs on servers, so keep in mind that such differences exist. With these issues coming to light, the fact that the model was eventually released as open source brings up the question of its potential impact. In the realm of developing AI services, there's a growing need for compact models that consume much less power during deployment. Wouldn't you agree? Otherwise, the larger larger the user base, the more burdensome the electricity costs become. However, it's clear that even these lightweight models can achieve satisfactory performance. This indicates that there isn't much of a gap between China and the US. The DeepSeek model and other models supported by the company show great potential, especially in terms of algorithmic scaling. Unlike the mainstream big tech companies in the US and China, which have been developing by just pushing forward, the focus on improving algorithms seems to be showing results. I'll keep following and showing you these aspects. This has been Era, who is rowing hard while the tide is in and uploading 5 videos a day.